All right, so we're going to take a look at finding some asymptotes. So vertical asymptotes are a little bit easier to deal with. Maybe not, I don't know, than horizontal asymptotes. And here's the trick with vertical or horizontal asymptotes. All functions can be written as a to the x to the m power plus, and that can go on. And the denominator in this case would be b, where a and b are coefficients to the x to the n plus, and then whatever. So, if m could be 3, 4, it could be any number. So these equations can be to any degree. And so the question when it comes to asymptotes that are horizontal, we have to look at these values here. So there are 3 situations. M could be less than n, m could be greater than n, and m could equal n. And so we have to remember what the rules are governing these asymptotes relative to the degree of the numerator and the denominator. All right, so if m is less than n, that means your horizontal asymptote is going to be y equals 0. And that will always be the case. Sorry. If m is greater than n, then there's going to be no horizontal asymptote. And if they're equal, that means the asymptote is going to be equal to y. There's the equation for the asymptote will be y is equal to a over b. So the question is, looking at our equation, which one of these 3 situations do we have? And we have an exponent of 1 in the numerator, an exponent of 2 in the denominator. 1 is clearly less than 2. So we're talking about this situation here. So the equation for the horizontal asymptote is y is equal to 0. When we're looking at vertical asymptotes, we're looking at zeros really in the denominator. Or obviously you can't have a 0 in the denominator of a fraction. But when we're looking for vertical asymptotes, we'd first need to reduce the fraction. And I can't help but notice that we have x minus 1 in the numerator, x minus 1 in the denominator. So those would cancel out. And so here we'd just be left with x over x plus 5. And so in this circumstance, we cannot have x plus 5 equal to 0. So I set it equal to 0 to figure out what x cannot equal. In this case, x cannot equal negative 5. Therefore, the vertical asymptote is x equals negative 5. I hope that's not confusing when I'm saying no to that and then saying it is equal to that. But in other words, you can't have negative 5 as x, therefore there's a hole, so to speak, vertically. All right, and that's pretty straightforward.